Hello, Adam.
Brian.
How are you?
I'm doing well. How are you?
Do well. I sound as good as I'm going to get. I'm just like I just am in a, as you know, I'm not in the litter box at the moment. I'm in a.
That's right.
There's a lot of tile in here. It's very bouncy. So
undisclosed echoey location.
Undisclosed echoey location. So yeah, I'm with my mom while she's recovering from a surgery, and my sister was just out here. And she's like, we got to get rid of all these carpets. These carpets are trouble for her. And I'm like, I'm kind of resisting her like rolling up all these carpets. And I don't want to tell her that the reason you can't roll these carpets is because of the podcast.
Look, the risk of mom falling, I get it. That's real. But we talk about reverb for a second.
Can we just talk? Do you know how much abuse we take over audio on this thing? Like I'm just. And people think we don't try. We do try. I try. I'm sorry.
Yeah, no, we try for sure. We're just bad at it. Yeah.
We're just bad at it. We're just bad at it.
It's much worse than not trying.
And, in my sister's way, she's like, you cannot give me one reason for leaving these carpets here. And I'm like, you know what? Correct. I can't. That's correct. Let's just roll it up. I'm just going to go. You know what? It is going to be way faster to apologize for this on Monday. So anyway, there you go. It's I'm reverby and with my apologies. Hey, good memory on this Austin episode that we did. How did you pull that out?
Oh, I was thinking about the Usenix ATC, which is spoiler alert, the subject of this conversation.
Spoiler alert. Oh my God, jumping into the intro so quickly. Okay, yeah, wow.
Yeah, sorry. Well, sorry for folks who wanted to listen for half an hour and then figure out what the fuck it was we were talking about. So I was looking at the history of the Usenix ATC, and I can't remember when Usenix ATC and OSD merged, but fairly like within the last 10 years or something like that. So sound right?
No, they didn't merge.
Then Wikipedia was wrong.
Really?
I mean, really, that's my recollection based on looking at Wikipedia recently. Yeah. It says in 2021 onward. Co-located. No, not merged. Co-located.
Co-located. Got it.
Co-located. Sorry.
Yeah, co-located. Yeah, even like it's like sleeping on Ozzy's couch. Which is like even kind of sadder.
Yeah. I mean, you're right. Not merged in the most literal sense, but I think like not inaccurate, right? Like co-located.
He's sleeping on Ozzy's couch. Ozzy's like, look, using it like ATC, you can't keep sleeping here. You got to go.
Right. I hear you've been telling people we've merged, but you're just sleeping on my couch.
Right. Yeah.
Yeah. Part of it. Yeah. So then OSD reminded me of put the OS back in OSD episode from a million years ago. From the Twitter Spaces days.
Years ago. It is truly, and I actually, like, God, I mean, that is from my early days. And like people think we complain about the audio now. We had accidentally lost the audio from the previous episode, which we spent like 20 minutes on that episode talking about like. So it was good to go refresh a little bit. Again, I'm really impressed you pulled it out because I had honestly forgotten it.
No, and I think it was. I did not re-listen to it, but it was about like I think Mothi Roscoe had given a presentation that was very like on the nose Oxide, especially at the time, as I recall.
Sure. Yeah, and kind of decrying the lack of real OS innovation at OSD and hitting on some similar themes for sure. And I guess I did not realize that ATC was sleeping on Ozzy's couch, which actually makes a little more sense now. It was kind of like it had been transitioned to kind of hospice care in hindsight. And did you? I don't know if you saw this announcement last week when it.
You know how offline I am, so I was particularly offline over the weekend and last week. So I missed that until you hit me up this morning. No, I had not seen that announcement, so I was catching up in a hurry.
And we have been, so I think I have been in some to 3 ATCs, and you've been to at least 2.
That's right. So we went with when the D-Trace paper that you wrote and then put my name and Mike's name on, I think is not inaccurate, but I'll take it. When we went, back then, and when we met Dennis Ritchie, by the way, I'm not sure we're going to get into that, but
we are for sure going to get into that. We have to get into that.
Okay. Good.
So this is like Run, Brian, Run and us eating horse and Ghent, which I am convinced we have retold 15 times on Oxide Friends. How many times have we retold the Dennis Ritchie story?
I think 0 times.
Oh my goodness.
Because it makes me a little uncomfortable to tell, at least the way I tell it. So I think I would remember it if we had told it to everybody.
Okay, yeah, the way I tell it, I think makes you even more uncomfortable. It doesn't make me feel uncomfortable, but maybe
yeah, that sounds right. So then
myself, do not let Bryan tell the Dennis Ritchie story.
Right. How can I move on as quickly as possible? Oh, here's a shiny object. And the next time was when we were receiving the Stug Award, right? For D-Trace. This is and you, speaking of your mom, she was there to watch you receive the award.
In fact, she had reminded me of that when we were talking about this earlier, and I completely forgot about that. And that was in Boston, I think.
Yes.
Right.
Yes. Yeah.
And then I went back for the ATC, which we hit on briefly in the episode that we recorded several years ago, and then I did reference in the blog post, but that they made this huge mistake of inviting me back to give the ATC keynote in 2016, very clearly not having done any research on me whatsoever. I would love to know like the backstory on how they clearly I was their 8th choice or something, and they
or somebody like lobbed in this apple of discord with your name on it.
That's another possibility, that it was an act of spite by the enemies of the organizer. It's like, look, I can't make the conference, but this is the guy you should have. This is the guy that you jerks should have give your keynote. No, that's also plausible. Yeah, it was hot. It was definitely hot, and was this the one
they put like a warning over? Or was that a different talk?
Look, I mean, you're going to have to be more specific. I know they had given, they had put a warning over my Lisa talk, another dead conference. I will thank you not to conflate my hot talks at dead conferences, sir. No, this is
a whole series.
It's a whole series, hot talks at dead conferences. That was in Lisa 2011, where I gave some unvarnished opinions on Oracle. Which it is almost like it is as if there's a bot responder on Hacker News. Whenever Oracle comes up, someone feels an obligation to kind of drop the reference to this talk. And at 33 minutes in particular, I'm just candid as far as I'm concerned. But they put a warning on the talk, and then they put a warning above my head the entire time I was speaking. Here, they didn't actually have a video. They had audio only. Right, which itself is like, this is not a good sign. This is like a cat that's no longer cleaning itself from a conference perspective. You know what I mean? Like, this is not good. This is not good. Like, but I think it also reveals that like the part of the kind of endemic problem in the annual technical conference is that it was no longer a conference in any way. And I felt like when we were there in 2004, so we were there to we described AA debug before in Ghent in 2003, but it was there that we were like, we really, in terms of like, we felt strongly that we needed to publish D-Trace, and we wanted to publish it academically. We wanted to do it in USENIX. And I think ATC, like Usenix ATC, felt like exactly the right vector, because that's clearly the conference aimed at practitioners. And, I was kind of floored about how low the acceptance rate was. The acceptance rate, when our year, 2004, was like under 13%, which is super low.
Yeah.
And this just means like you're just throwing out good stuff at that level, unless you are just like attracting total turkeys when you are at that level for a conference. Like, there's going to be good stuff that you're rejecting. And I don't know. I mean, what do you remember about ATC 2004? This is a long time ago now.
I remember being. I'm trying to remember that it was like kind of Nutella Networks mania is what I remember. It was sort of like
Nutella, like the chocolatey spread.
Wasn't that what they were called? Like these massively distributed networks? Help me out, chat. Come on, I'm not making that up. Yeah, I thought like it was the network named after the chocolatey spread, chocolate hazelnut spread network.
Okay, yeah. Okay. And then what else happened?
in this dream that I was in.
Exactly.
No, I remember a bunch of talks on these subjects that felt kind of very abstract, but like the kind of thing that is, what it felt like at the time, achievable with the resources of a university, which sort of makes sense, as opposed to sort of some of the stuff that we had been doing at Sun around massive multiprocessing, things that were novel in that 2004 era, but were pretty inaccessible or tough to access or expensive for university students. So it didn't feel, I don't think we walked away, or I didn't walk away feeling like there was stuff that we learned that we could apply when we got back to Menlo Park.
For sure. And I think I was also just surprised. I know I was surprised by the fact that we were the only folks presenting a paper that were writing software for a living. That everyone else was basically in a lab or a grad student. Like I just think I thought it was still, those proceedings from the USENIX proceedings from the 90s, where I love everyone in the chat trying desperately to help you out on Nutella, by the way, Adam. I think it's the Nutella stuff, maybe. But I just remember those because like Bonwick had done the slab allocator paper, right? In that the summer USENIX 94, and just like you look at those mid 90s USENIX proceedings, and we're like, NFS 3 is a paper, it's like, wow, okay, and it just felt like, wow, this is like big industrial stuff. People that are at, at the time it was at Sun or SGI or HP or what, at like doing real systems, presenting their work, and I just assumed that ours would be one of many like that, and it's like, oh no, it's like just us. And then after every talk, they'd be like, and hey, just as a reminder, this person is looking for a faculty position.
Right.
And I'm like, this is really just not what I was expecting. And this is in an era, this is where we sound like, down at the Gen X home in Dickety 2, of like, this is like, that talk is not recorded, the one that we gave.
Really?
On Dtrace.
Yeah.
Right? It literally isn't. It's not recorded at all.
That's kind of crazy.
Do you recall that we had 20 minutes to present that entire paper, which was all of Dtrace?
I do. And you generously say that we presented it. You presented it, and we're talking at full speed, right? Like full throttle. Bryan speed.
Full throttle. And in many of my talks, if you listen closely, because I insist on being able to see a clock, especially if I got a time bounds. Unlike this podcast, which of course just destroys all of your domestic life with its total lack of adherence to a time bounds. But exactly, you need the clock in front of me. But you can hear me like see the clock in some talks, and all of a sudden you're like, okay, what just happened? Like we just launched, and it's like, oh, because I was only like a quarter of the way through my deck and had exhausted half the time.
Right. That feeling when you're like cruising along at 25 miles an hour and realize that like you're definitely not going to make it on time and gun it to 75.
That's right. In contrast, that talk, not recorded, was like, we don't have a chance unless like we peel out of the garage at like 125. So I don't think I ever put more content into 20 minutes than that talk. And I'm like, and it's like, I'm sure ill-advised. I'm be like, I need to present this entire like body of work that the three of us had worked on for 3 years in 20 minutes. And it was, and I'm like, and I need everyone's attention to do it. And I definitely got everyone's attention because, like people, I will induce a fight or flight reaction where people are afraid to look away because they are like, they've got this animal reaction is engaged. And that's what I recall from that talk. And our friend Peter Galvin, who we've known for years, and Peter co-authored one of the great OS textbooks. Peter looked out over everybody, and because there was kind of like silence after like I hit time, basically. And Peter's like, everyone looks like they just got off of a roller coaster. It just look like they are. So yeah, and that not Not recorded. And then, but I just remember us doing and then of course the first question. You remember the first question?
It must have been something like rage-inducing, like Linux, or what's the license? Probably Linux.
Yes, Linux. This is before open source, so it's of course there's no license. Like, when are you going to port this to Linux? You're like, yeah, okay.
Was it? So I thought we open sourced dtrace in 2003. Is that not true?
No. We shipped it first to customers in 2003.
Oh, pardon me.
January 2005.
Excuse me.
This is kind of in this this is kind of interesting, right? That's a really good point, because this is the world's only introduction to the thing we've done. We live in, we're kind of in this era of proprietary systems, and like, this is kind of it. Like, there's not you can go get the manual and so on, but this is not, it's a proprietary era. We haven't open sourced it. There's not a GitHub repo. Like, this is our way of kind of projecting all of this, of letting people know what we've done. And it's like a really different era. It's just a long time ago now, and do you remember Bridget was there?
Oh, really?
Very, very pregnant with Tobin. My now 20-year-old.
Wow.
Yeah.
So do you remember what was I remember another thing I remember is you really thinking that we were in the running for best paper, which I don't think we were. Do you remember what paper won best paper?
I don't even remember having that hope, sadly.
I remember when they were announcing it, you were like vibrating, and Mike and I thought were being very supportive. But I would say, in your defense now, years later, I Googled it because I was trying to figure out who it was. And the AI overview says that the paper, and I don't believe this, by the way, and you'll see why. It says it was given to energy efficient prefetching and caching. Okay, plausible. I don't believe it because it says
sounds like a dumb idea.
It says this paper was presented by Brian Cantrell, Mike Shapiro, and Adam Leventhal, and focused on dtrace.
I like it. I think the AI is not totally wrong. I think the AI is half right.
Sure, we'll take it. Take that win, I guess.
We'll take one.
Weird. I don't remember that being the title, but fair enough.
No, I'm pretty sure the best paper went to inhalable insulin at that conference.
That's another deep cut. That was the Wall Street. So Wall Street, this was the proudest moment in my career, or a very proud moment in my career, because I could finally explain to my parents something that I had done, or actually, I could just give them something to coherently brag about, which is when we won the Wall Street Journal Award for Technology. We beat out inhalable insulin, and so it made it very easy to explain something that we were better than. Although it turned out inhalable insulin was kind of like not good. Is that right? Is that fair to say? Didn't make it?
Well, I would say it was more that people had drawn the inference that we felt that inhalable insulin was not an important problem, and that actually misbehaving systems were actually much more important than actually helping people who are diabetics. So I just remember people being like, where did you kind of get, like, why do you think you're better than inhalable insulin? I'm like, I don't. They do.
The Wall Street Journal does. So
the Wall Street Journal does. So I don't know. By the way, we're inhalable insulin, so where's your inhalable insulin now? But no, I had forgotten that. I got my hopes foolishly up. I should have got my hopes up because it was an academic conference. But
exactly.
And they're and how many attendees do you think were at that conference that year?
I mean, it felt busy. I think
it felt busy. Yeah, I agree. I think that there were like 150 or 200 in the room where we presented, which was right. I think it doesn't feel like a huge exaggeration. I feel like there were like on the order of 400 to 500 people at the conference.
Yeah, I was going to guess like 500. So yeah.
And apparently it hit a high close to 2,000 in 2000. It hit like 1,700 or something like that in 2000. But there were definitely, so I think that year that we were there was very much a shoulder year where it was, and maybe that was the first year where it was transitioning to really being an academic conference versus a practitioner conference. And now that said, there were practitioners there. Is now the time that I get to make you feel uncomfortable by telling the search story? Or why don't you tell your version that has the least amount of discomfort?
Well, just me telling it has discomfort, but I will say, so we saw Dennis Ritchie was there. I think we had kind of seen him and then kind of bumped into him in like, I think literally as we were kind of passing in a hallway or leaving one other talk. And we were really excited to talk to Dennis Ritchie because obviously we had drawn tremendous inspiration from his work. There's like C and awk and like there's all kinds of stuff in the design of dtrace that we wanted to show him and talk about it and geek out about, and one of our, I think, collective heroes. So we maybe came on too strong. As he was not cornered per se, but like certainly quickly got the look of like a caged animal. As we kind of confronted him, laptop open, kind of telling him how excited we were to show him this thing. He explained that he needed to go catch a train right away. And then I think all of us agreed, sprinted into the women's bathroom.
Yes, he definitely ran away. We cornered him with a demo and accosted him with a demo. I don't feel that that's like
yes.
We were just
not a crime, but there is yeah, exactly. We were excited.
We were excited,
yeah.
And
he was less excited.
He was a lot less excited. And he wanted to be polite and said that he had to run for a train, but then in his fight or flight motion did not go to the exit, but dashed into the bathroom. You inserted the wrong bathroom, but he went into a bathroom, of that I am certain.
We can definitely agree on that.
And we're like, well, what do we do now? Because he's definitely like there's no exit in there.
So what do we do, dear listener? We followed him into the bathroom.
No, we did not follow him into the bathroom. We did it, but it was a moment of deliberation. Like, do we stake him out? I definitely remember us joking that we were going to go into the bathroom and look under the stalls, and he was going to be standing on one of the toilets, just terrified of please don't make the demo come back. Please make it leave.
I will say there are not many times in my career when I've been incapacitated by giggle fits, but that was one of those times.
The idea of Unix pioneer Dennis Ritchie standing on a toilet because he was afraid that we would accost him with a demo,
and us staking him out, us kind of looking under the stalls, us doing a bathroom demo of dtrace, all of those things, I think were fairly incapacitating for me.
Yes, I do think that, as I recall, we had some kind of vivid fan fiction for ourselves of sitting in the next stall, loudly doing a demo. We had a whole bunch of ideas. Poor Dennis Ritchie, and Dennis Ritchie, I think, was actually just candidly was beginning to decline at that point. I think we did not stake him out. I feel
that's right. We took I need to catch a train and go into the bathroom instead as a clear signal that he was not that interested in our demo, which is fine.
Right. No, we drove through all of the other social stop signs that indicated that I am absolutely not interested in this. It was I need to catch a train while running into the bathroom. And it actually took you know what? I think he might not be that interested in this.
The social restraining order. Yeah.
Based on this restraining order, I think he's not that interested in our ideas. So yeah, sorry to the late Dennis Ritchie for giving you a fight or flight reaction. But then I'm trying to remember we had a BOF. I do remember that we had a BOF that night. That was pretty interesting. We got there were some good conversations. But then I kind of got back and I was like, man, that was really not what I was expecting.
Do we need to explain what a BOF is? Is that a thing that everyone knows?
That's a good question. Is a BOF? That's we might. Yeah, BOF.
I don't.
Go ahead.
Because conferences are kind of. I feel like they're. Back then, I think we could count on our colleagues having gone to conferences, being familiar with, and I don't think that's the case anymore. So
yeah, that's fair.
You want to take on BOF?
Yeah, go for it. Take it away. What's a BOF?
BOF is Birds of a Feather Session. Kind of a weird name. I thought. I continue to think, and it's a sort of focused mid-conference get together on a particular topic. Is that accurate?
For sure. It's apparently a DECUS term from the DEC user group.
Wow.
It is a weird Birds of a Feather is it's Birds of a Feather Stick Together is what it's a reference to.
Right.
Well, maybe that wasn't obvious, but also a very antiquated kind of folksy saying.
Very folksy. Right. I mean, a kind of thing that, like, even as you say it, I'm like, could I convince my son that that's a real term, like expression? Probably not.
I think you're right. I think that definitely sounds like that's a. I think like certainly my 17-year-old would be like, that's a Simpsons reference, but I don't know which one you're making. I'm like, no, that's not that's not an Abe Simpsonism. So yeah, goofy kind of term, but basically it's a group of folks that get together. It's a little bit of structure on the hallway track. We're gonna like actually get some beers and those were like really important. And I'm sure I know they still exist at conferences, but like especially in kind of that earlier era, this was the way that you would exchange ideas because it just was not like things were just not nearly as online. So obviously in 2004 that was changing, but certainly in 1994 it's kind of like that or Usenet. I mean, there's not a whole lot of other vehicles for this stuff. So so we had a BOF session on D-Trace. I remember that night, which is great. But I don't remember, like, coming back from that, I'm like, that was just not what I was expecting, which is part of what prompted me to kind of write this blog post on, like, what's going on with this conference that I titled With the Usenix. And, like, it feels like this should have been all practitioners, and it's not. It's all academics. And I kind of went into a bunch of other conferences that I thought kind of should be similar, and you get a lot more kind of academic practitioner co-authors on papers, and that was definitely not the case. And they also had Freenix. Do you remember Freenix?
No.
So Freenix was this like short-lived, I think again, because to Usenix's credit, Usenix was awake during the surgery. They definitely knew this was happening. Like that this is because I don't know if you read Rick Farrow's piece that I linked to. Like, so there was a very, very good piece that was written after I gave my very hot ATC 2016 talk. So Rick Farrow wrote a very good piece talking about kind of the history of Usenix and how like academics and kind of deliberately sought out Usenix ATC because it had a big audience. And that big audience was really attractive to those academics. So like there's a degree to which and the kind of 2004 again is one of those shoulder years where the academics are now kind of like now coming to control all of ATC, and they know that this is happening, so they want to kind of create this other track, Freenix, which I don't think Freenix lasted more than a couple of years. I think Freenix did exist in 2004, though, which was around actually open source software, which was kind of interesting. But the standards were much lower. It just wasn't like people weren't really paying attention to it, so it kind of withered.
Was it sort of like OSCON, like adjacent in the early days or something? Was it a similar kind of vibe?
I think that was kind of the idea, but I actually thought it was a good idea, and I don't know why they discontinued it because I kind of thought that it was this kind of referee track. Let's get started in 2001, so I think in 2004 it definitely was still happening, but I think it was kind of done by like maybe 2007, 2006, 2007, and I think that the idea, the hope was that you would create this vector for what we would call more like practitioner authored content. And I was like just looking at like the Freenix 2004 track. I was like, yeah, that actually looks like that interesting. Like that does look better, or at least it looks like. I mean, like just looking at the Freenix 2003 agenda. I mean, you got like the flexibility in ROM, a stackable open source bias, right? Like that's all right. I want to go dig that one up. That seems interesting. I mean, there's some interesting stuff in here, at least stuff that seems germane that was not going to be in Usenix, in the Usenix Annual Technical Conference, Usenix ATC. And so this kind of like, there's beginning to get this kind of stratification where you're getting this all academic conference in Usenix. And I was kind of going back to that. It's kind of amazing. I had this, I can't easily resuscitate the comments section, unfortunately, for our old WordPress blog. I need to find a way to do that because the comments are kind of amazing for this. It's like I am going back and forth with Werner Vogels in the comments, having like meaningful discourse. It's just kind of like, wow, that's the comment section for a blog. Used to be where we would.
It's crazy, and that was the only place, right? Like, I mean, maybe on like news groups or something like
yeah, exactly, yeah,
or like IRC, yeah, or /dot exactly. But like, where else are you going to have that? It's even the thought of a comment section of a blog is sort of so quaint right now. Yeah, right.
I know. It's very quaint. And we're kind of going back and forth on this stuff. And, and basically, like, he saw the same problem that we saw, which is like academia is controlling this conference. It's lost the practitioner content. And the question is like, how do you get that back? And, do you... And, Werner's point was like, look, we need more practitioners to be on program committees. Like, if you don't have more practitioners on program committees, we're not going to go solve this problem. I thought it was more on Usenix to find a solution to this. I think it's a little bit much to have you been on a program committee ever?
Only your program committee. So should I count that for Systems We Love?
Systems We Love.
Yeah,
that was a good. What did you think about that program committee? Yeah, that was
great. It was great. I'm just annoyed with it. They didn't accept my paper. Those jerks.
Is that true? That's pretty funny.
But it's okay. It's okay.
Yeah, we did because it was Systems We Love, which was this conference. I had unspent marketing dollars. I don't know, this is the origin of this.
The thing I love most about it is the unspent marketing dollars went into this conference for which the T-shirt forgot to mention Joanne, Triton, like any of your stuff, right? It's like just the logo. Yeah,
it's a great T-shirt.
Amazing T-shirt. It's just remarkable that like those excess marketing dollars couldn't put up a logo on it or whatever. I'm glad it doesn't have it, to be clear. It makes it much more wearable. But great marketing.
May we all be blessed with unspent marketing budget that has so few strings attached. So we basically had to spend $40K in 45 days. And I'm like, I can do it. I can do it. I can do it. And I was trying to do Systems We Love, and because actually it was coming after this 2016 ATC talk that I gave. I was actually, we'll rewind just a little bit. We'll kind of get to Systems We Love in a second. But we were kind of having this back and forth about the right way to get folks engaged. In 2010, I was asked to be on the program committee for OSDI, for the operating systems, and we talked about OSD in our previous episode. And it was really, and I will direct people to my ATC keynote on what a disaster it was, but it was a disaster. The program committee was it was really, really, really bad.
Wasn't didn't you have someone like Keith or someone else on that program committee with you? Didn't you have someone else in industry to at least commiserate with?
Keith asked me to do it. But I think he was not actually. If he was, he certainly was not in the meeting, the program committee meeting, and maybe he wrote me into it. I can't remember if he was actually on the PC or not. It was bad because I was one of extremely few practitioners on that PC, and every paper that I liked plenty of papers, but those papers were all killed. I was the only one that liked a bunch of papers. People were like. It's that same criticism that we've seen before, right? Where I liked something because it was real. Academics had disdain for it because it felt small or insufficiently novel.
Interesting.
And I don't know if you actually, I don't know if you went through some of those old blog entries. Do you know what I held up as an example of something that's small but interesting and real?
No, tell me.
Nohup minus P.
Right. My great claimed improvement on the late Joseph Osana's nohup. No-hupping a running process. Yeah.
So could you describe nohup minus P? Because this is something that I mean is is this expansive? No, but it's actually real and it's tricky, right? It's actually a tricky problem.
It actually intersects with my proposed topic that for Systems We Love that you rejected. If folks have run nohup, and now nohup minus P is also on Linux, but way back in the day, what would happen is I'd go to build the Solaris kernel, and the way you did this is with a command called nightly. Now, dear listener, how long do you think it was expected to take if the name of the command was nightly? Okay, so it took a minute. It took a while.
At one point, it took 25 hours, by the way. That was actually a real moment of crisis where it's like, it can't be fortnightly. It actually has to be nightly. We have to make this thing go faster.
So you'd start running nightly. It would churn for like an hour of the 25 it was planning on run. And then you'd realize that you had forgotten to nohup it. And like, you'd be wanting to run out the door or whatever, but not being able to kill that terminal session. So, nohup, the right way to run your command was under nohup, so that it would mean that when you closed your terminal, it wouldn't kill off the process. But the way that everyone ran it,
tree was to plant one, Adam.
That's right. Right. So this was like, I think this would annoy us for everyone, but particularly for me, because I would always forget to run things under nohup. So say, why can't we do it after the fact? And nohupping things after the fact turned out to be fairly tricky, and involved, in our implementation of Solaris, the use of the agent LWP. I'm not sure if we've talked about that.
We have not. No.
Maybe we must have. Yeah. We one of the, maybe for episode 2, I think, was, or maybe 3, was talking about. We talked about Roger. No, we talked. I think the title of it is like /proc to proc macros. So it's not impossible that we've talked about it, but it's been.
Are you like Rain Man for Oxide Friends? Like, you mentioned the agent LWP and you're dropping the episode number. This is insane.
Yes, I am.
Okay. All right.
So anyway, you said the agent LWP deserves several episodes all on its own if we haven't done it yet, or maybe a talk at a conference someday. But the nohup -p allowed us to.
You have to give a little more context for the agent LWP.
Okay, agent LWP is awesome. So agent LWP is, and I think it's not just awesome in its own right, but it's a really neat programming model. So, I think that a lot of other systems have ptrace. Ptrace let debuggers kind of do things to a process. Roger Faulkner, one of my mentors, may he rest in peace, one of our great inspirations at Sun, colleagues at Sun, invented the /proc file system, and he invented this cool mechanism called the agent LWP. And what it allowed you to do is send in an LWP, effectively a thread, to do work for you. It's amazing. So you could send in this thread, and the thread was very bare bones. Like, if you wanted to have a stack, you had to make a system call to mmap some memory to get it a stack, and it could do all kinds of work for you. So is that a fair synopsis of the agent?
It is. It wasn't always that way. It used to be that you would stop the process, and then you would hijack an LWP and make it execute system calls on your behalf. And Roger kept tracing. So you basically, like, the process is under like general anesthesia, right? And it does not know that it's out. It's stopped while you're controlling this. You would pick this representative LWP, and the representative LWP would do this work for you. And the problem is he kept chasing these bugs where there would be these little artifacts that would be left behind where your architectural state from an LWP perspective would be subtly wrong. And they were becoming impossible to clean up. And the reason you want this at all is because if you can have the process act on its own behalf, albeit at the behest of a process that's outside of it, you can ask any question about the system. Right. So, yeah.
Not only that, but you don't need to invent like an alternative world in the debugger. Like,
that's right.
I mean, you don't need sort of the system call for myself or system call for somebody else. Open a file for myself, open a file for somebody else. But rather, the agent LWP was a way to make use of all the stuff that a process could do, but execute it remotely. And then as rather than kind of hijacking a particular thread, one of the neat things about the agent LWP is that if it is present, then all other threads are stopped. So it allows for cleaner semantics on the behalf of the debugger.
Yeah, what was the sitcom with the girl that stopped time? I
do. I'm not gonna. Out
of the world.
Nice. Well done.
Out of this world. Did you ever watch Out of This World? It was like
I'm sure I did.
Back to back with Small Wonder.
I remember Small Wonder.
I actually think that children should be forced to watch these things just so they can get a little more appreciation for how bad it was when we were growing up. You got, as you say, like, if you are just in the context of the agent LWP, you know that everybody else is stopped, which gives you some luxuries about it. Like, you know some things about it. So how did we use the agent LWP? Why did nohup -p necessitate the agent LWP?
Yeah, so let's see. What you need to do when you're doing a nohup minus P is like close all of the file descriptors, that like a closed file descriptor 0, 1, and 2, and then reopen them to like a new file, right? So rather than sending output to a terminal, you'd send it out to a file. And as I recall, like you need to send in the agent to go close those file descriptors. And also, I remember there's some subtlety to it. Like it sometimes it would block. Sometimes you had to actually just wait for, if there was an intervening IO operation, it could cause the close to fail. So you had to like nudge things forward until the file descriptor became closable. But then once you got everything closed up, then you could reopen those files or reopen those file descriptors to the place where you wanted the process to send its output.
That's right. And it's like, which is like, just there's like a lot of tricky details to get right on something that just feels like, can't you just do this? Like, why? It's like, no, there's actually, it's really complicated. It's complicated. And it requires this, like a bunch of mechanism that if you didn't have, you would need to invent, basically.
Right.
And I like use that as an example of like, this is something that like academia would view as trivial and uninteresting, that we actually viewed as like, no, it's actually like pretty interesting. And it's definitely not trivial. It's actually hard to get all this stuff right. And we like that stuff, but they're like, no, we do not like that stuff. That stuff is not, and I think it kind of showed that like that disconnect that like, no, we want the OS research or research should be, we emphasize novelty over all else. And for a practitioner, it's kind of utility over all else. And the novelty is like, great, but it's the utility that trumps the novelty.
Well, I was going to say also it's that sort of last mile, right? Where I think in research, it can be sort of boring or sort of beside the point, or maybe past the point that you need to, in terms of a little bit of the distinction I felt early as an engineer, the difference between completing an assignment and shipping a product. Where you're like completing assignment, it's like, yeah, like it works, like most of the time or whatever. Like maybe sometimes it doesn't, but like, what's the big deal? As opposed to systems programming, where you're like the tests and the edge cases are everything, right? Like that last mile is everything. And I think that was some of that dichotomy that we were seeing between the practitioners and the academics.
Totally. Did you take Morris's lock and wait free data structure course?
I didn't actually. No, I didn't.
Did you work with Morris? This is Morris Herlihy, a prof that we had in common. Really a super interesting prof. But so he, in that course, I loved it because you, like the entire coursework for the course was taking a research paper and implementing it. And effectively everyone that implemented the research paper discovered a bug in the research paper.
That's awesome. And not surprising.
Well, actually, I'm not sure if maybe we haven't said it here, but so Mike was working with Tim Brennan. I'm not sure if you know Tim.
Yeah.
So they were working on implementing the diffracting trees, which was this hot new weight-free data structure from this guy near Shavit. And so they implement it, and it's like the results are just like terrible. Like the results are way worse than like just doing the dumb thing. You know what I mean? It's one of these things that like diffracts contention. So you end up, you kind of look at it and you're like, is that going to pay the freight? Because that's really optimized for contention. And you're going to do a lot more memory accesses. So it's like, boy, if you end up like hitting a line that's not there, like you're going to endow it. And so it's like, I don't know. I'm kind of skeptical about it. So it's like, they go to implement this thing and it's like, doesn't work, or it's the performance is terrible. And if I told you this story, this is an amazing story. So they are like, okay, we're screwing something up. So they kind of went back over it and like, okay, we're screwing something up. Like, no, we can't find it. So then they go back they mail Shavit, like, hey, like we're struggling to replicate this work with like something that barely exists in academic computer science, like replicate the work. We're struggling to replicate this work. Like, can you help us out? And of course, he's like, I didn't actually do the implementation. Like, my grad student did the implementation, right? So they get handed off to the grad student. They're having some communications issues with the graduate student, and they're just not able to get like they can't find how they've misimplemented this thing. And Mike's getting increasingly frustrated. And finally, it actually like a pretty good idea. And he says, like, I am doing exactly what you're doing, and I'm getting literally the inverse of the results you're getting, and I don't understand what we're doing wrong. But all of this is like before SMP machines really existed. I mean, they existed, but they were not so prevalent that you could do research on them. So they were using a simulator for this, not an actual machine. And so Mike is like, give me the configuration for your simulator. And in the configuration, you specify, and you want to parameterize the simulator. So you specify all these different like latencies effectively for all these different kinds of accesses. They had configured it such that a local access in cache, yes, a local access in cache took longer than a remote cache hit from another CPU.
Yeah, I mean, that'll do it.
That'll do it. It's like, hey, I got to tell you, like, it's a real green field for algorithms in upside down Alice in Wonderland can't be built world.
Yeah, if you're like, if your cache has a negative impact, then yeah.
It's like, wouldn't I just turn it off? That's another paper right there, my friend. Like, why don't you publish that? Yeah. No, it was so, and this is like, this should be this was happening right when Cold Fusion, which is now, I think people think of Cold Fusion as kind of like a Theranos-like brand, or maybe not. But Cold Fusion, this group at Utah thought they had Cold Fusion, kind of desktop fusion, and they didn't. And it was like, there were...
Is this like late 90s? Like this is...
It's like mid-90s, I think. Or even I think this... even like early 90s. When was that? And it was it was in the kind of that era, and it was a big scandal, of course, when this computer. It was like the superconductivity thing that happened. Remember, it was like there was like there was like 3 days online when we thought we had room temperature superconductivity.
I do remember that. Right? Yes.
And everyone just kind of lets their imagination run wild on that single result. And it's like, wow, this is like, we're gonna actually like have world peace with room temperature superconductivity. It's like, oh, it turns out the results were wrong. It's like, oh, right.
So this is 1989. I just looked it up, and I think
1989.
I think there was a time, like I must have been like right then, when like maglev trains were like going to be real, and like everyone was going to kind of travel on maglev trains, and this was like the kid like.
Haven't we been on a maglev train together? Shanghai.
Oh yeah, I guess there you go. But
it is very expensive.
We don't have them everywhere. You
we do not have them everywhere. Right. We may have noticed. Yeah. I'm on my maglev train right now. That's why the audio is so bad in here.
I'm calling from the maglev.
You're right. We don't, and there was this kind of idea, and Cold Fusion was a big part of that, and had become this big scandal. And I'm like, this is a scandal? Why don't we publish this? And I remember, and I'm like, well, this is like, they should go publish this at a conference. And we're just like, you could do that, but if you were to publish this, this paper was probably data with best paper, probably beat out something that was much more deserving. But if you do this, they're just going to spend their entire life trying to invalidate your results, and no one wants that. Basically, like, no one wants to. You might as well just go do something else. And I just remember being like, God, that just. I mean, it felt really. But it was also kind of, I guess you can kind of take that one in two ways. One is it is pretty disheartening. On the other hand, it does. For another kind of lesson to draw from that is like the details really matter in systems, and you can have an idea that seems valid all the way to the end, and like, whoops, there's this one detail you were simulating an impossible computer that actually completely invalidates it. And you actually need to be able to have a system that's completely implemented to be able to actually really validate the idea, which I think is like kind of a central. I mean, I don't know. That's a belief that I think you and I definitely have.
So yeah, have I told you about my own brush with a paper that I couldn't? No. So this is very relevant, actually. So we implemented ZFS RAID Z, then we implemented RAID Z2, so double parity RAID, and then when I was going to implement triple parity RAID, I could not get the math to work. could not get the math to work was in particular recovery scenarios. That is to say, if I have a stripe of particular width and I have failures of particular drives that should be recoverable, it was not recovering. And the paper said it should work. And I did the math, and kind of, it was one of these things.
It was not working in the notebook, or it was not working in the implementation?
Not working in my implementation. So single and double parity implementations were done and shipped. In the meantime, triple parity RAID was not working in my implementation of it. And I would also note that this was a highly stressful moment for me, because I was thinking, did we not sufficiently test single and double parity enough? Like, have we shipped data corruption?
Yeah, and, why? When were you working on this? And this would have been like 2007, 2008, something like that.
Yeah, this was at Fishworks. So Fishworks for sure. So then I'm this is causing me now to like go back to the abstract algebra that I ostensibly learned in college. And this is another great example of the difference between learning and implementing. Like, I thought I understood abstract algebra, and then I needed to go apply it to a real task. And then I realized how little I actually understood. And it turned out that this paper...
Can I just ask a question? Like, isn't the whole point of abstract algebra that, like, aren't you talking about it, like, concrete algebra? Like, isn't the whole point of abstract algebra that it can't, like, it has no actual, it can't be reduced to implementation? I mean, it just feels it's...
No. So this, like, that's where we learned about Galois fields.
It's like a theory, right? Yeah. Okay, yeah.
Exactly. So the Galois fields, which are very relevant for erasure encoding and that kind of stuff. So, exactly what RAID is supposed to be doing. So, finally, I kind of learned enough to figure out, okay, this under these conditions, it doesn't work. We had used this paper by Peter Anvin for the single and double parity RAID and then triple parity RAID because it was so easy to implement efficiently. It used kind of this kind of more efficient implementation. So then I go back, and it turned out years later, they published an addendum that's like, oh, yeah. You remember that simple matrix that we told you could apply and how it could use simple operations and be executed very efficiently? That's all not real. And you actually need to use this much more complex matrix.
Wow.
But we got away with it in triple parity RAID, and only triple parity RAID. Quadruple parity RAID would be much harder. Because 255 has 3 prime factors, and that was like a key insight that allowed us to get triple parity RAID going.
So were you able to get it fixed? Because I remember we had RAID Z3, right? So
we do have RAID Z3, and because 3, 5, and 17 are the factors of 255, you were able to construct the Galois fields in such a way where it is recoverable independently, regardless of which disks might have failed. But it took that. It's sort of like, because of that, it works for triple parity RAID. And if you wanted to go for wider RAID or more parity disks effectively, or additional parity, you would have to use a slightly different scheme.
That's really interesting. And of course, like, this was an idea. I mean, these were these super wide stripes, right? This is were we talking about like 46 plus 3 stripes or something like that? I just remember this is. We were like looking at a thumper, which was like 48 drives or something like that. 48 drives, right.
Saying like, we're going to do like
44 plus 3 plus 1 or something like that. Yeah,
exactly.
And it's not like the economics begin to break down too, because like those ultra wide stripes have got other problems associated with them.
Yeah, some IOPS challenges.
Exactly.
But yeah, another. I mean, in this case, they had themselves published an addendum, although we had not noticed the addendum until after we had implemented double and single parity RAID. But it was like sort of an exciting moment when you're like, I'm worried that all the integrity that we think we shipped actually is just latent data corruption.
Yeah, we've just gotten lucky the entire time. Yeah, oh my God.
But RAID Z users, no, you have not just gotten lucky. I mean, we got lucky in that it works for exactly up to RAID Z3.
Yeah, wow. Well, but again, it's like it was the implementation and the testing the implementation that got you to a flaw effectively now.
Exactly right. Yes.
And it's like great when stuff is provable, but that doesn't happen very often in system software. And it's so we Yeah, God, that is really interesting. Well, and I mean, this is why like you need the implementation really matters. And just like over and over again, you see these ideas where it's like, this is not implementable. And I think that was part of the frustration with the kind of academic systems work. It was kind of going where it was stuff that was, because it's on the one hand, they would kind of deride something like nohup minus p as being too small. On the other hand, the stuff that like a grad student can do in a couple of years is also not like expansive. It's not like, I mean, it's really like that work is actually kind of bounded in size. Mm-hmm. And I mean, this was the subject of Rob Pike's polemic. Did you go back and relook at that polemic?
I did. Yeah.
Yeah. And do you remember that coming out? I mean, I definitely remember that coming out at the time. What was your?
I do, but I mean, I remember reading at the time, but I don't remember. I don't remember in detail.
I just remember being like, I think this guy is like, he's making some good points, but he's also being like way too reductive. And it's like, it
sounds like Rob Pike. Yeah.
It does sound like Rob Pike. I know. And it's also like got this like funny, I mean, I do wonder, is this the original formatting for this document? Like, I think it is. I think this is just like the original formatting is just like, it's not really a slide deck. It's kind of, written anyway, whatever. Dykstra would be very horrified by this thing. But I think he was like, there's not enough like big things happening. And then the irony is that like he ended, and maybe this is like he wanted, it'd be interesting to get his perspective on this. Is he trying to be, did he end up being the difference he wants to see in the world? Or is it kind of happenstance that he almost like showed this to be incorrect by doing Go, right? And showing like, and maybe he doesn't call that research. I'm not sure. And maybe that's where it hinges on. I don't know.
Yeah.
But his things to do slide, I think, is really interesting. Like, go back to thinking about and building systems. Narrowness is irrelevant. Breadth is relevant. It's the essence of system. Work on how systems behave and work, not just how they compare. Concentrate on interfaces and architecture, not just engineering. That's like, okay, I don't really agree with that. Be courageous. Try different things. Experiment. Try to give a cool demo. Definitely agree with that. And then funding bodies fund more courageously, particularly long-term projects. Universities in turn should explore ways to let students contribute to long-term projects. Absolutely agree with that. Measure success by ideas, not just papers and money. Make the industry want your work. And I think that's like that. I think for academic systems work, that's been a struggle. But then when I look at kind of systems research writ larger, it's now we don't rely on Usenix or any other academic vehicle to, even like with ZFS, there's not a ZFS, but there probably should be a ZFS paper. But for the stuff we did after that, we used like either ACM or blog entry. I mean, blog entries were obviously really important. Like, we just didn't use the kind of the academic publishing vector as a publishing vector. Which I think
it's just lost its relevance for us, right? Candidly,
yeah,
both based on the observations we had in 2004, but then, as you say, like this was the dawn of blogs, right? This is before Twitter. There just became lots of different ways to reach our audience.
And the thing that kind of sucks about that is that you end up getting, I think, less cross-pollination between academia and the practitioner, which I think would be good if there were more cross-pollination. And that, I think, is the kind of the big thing that we lost. And this is where you kind of get to this thing that I did. So, this program committee that Keith had talked me into being on in 2010, it was a disaster because I was kind of the only practitioner. And the papers that I liked did not make it to the program committee. And so what it meant was that on the program committee, and obviously, like, the stuff that everyone agreed should be accepted, we didn't talk about that. We probably should have. Actually, it would have been a lot more mentally healthy to be like, no, like, let's take some time and talk about the stuff we all agree on, just so we can be like happy. But we didn't do that. That stuff we just admitted. And so all of the time as a program committee, you're arguing over the stuff that's on the bubble. And I was always on the other side of like, no, this is like, this idea is not implementable. And never alone. There's always someone else in the room that was arguing with me, alongside me. But goddamn, I was arguing against the entire room so many times over. And at the end of the day, people are like, "You're a really negative person." And I'm like, "I'm actually not. I've been in this position all day where I'm arguing against stuff and arguing about keeping stuff out, and I just hated it." And then the way, like after the fact, the program committee chairs decided that they didn't admit enough things. So one of the things that I had successfully kept out of the conference, they just decided to unilaterally admit to the conference. And actually, it was funny because like I wasn't even like at that point, I'm like, I actually don't even care. But that like weaponized everybody else. There were a bunch of other people in the program committee that were super upset by that. I mean, probably for good reason, because the program committee was a lie. But then when Usenix ATC in 2016 had me come back and give this keynote again, huge mistake, didn't do their homework. I'm like, well, I'm going to like talk about everything that's broken in academic computer science and the fact that we use conferences as the publishing vector. Like we're the only discipline that does this. And every other discipline uses journals or something that looks like it. And we seem crazy. I mean, if you've ever like talked to a neuroscientist or a biologist or whatever and have you done this? You explain what we do in computer science?
Yeah.
And they're like, what are you talking about? I'm like, I know. Why
do you think that is? How do we get here? Like, why is that the way it is?
Oh, I think it's the way it is because in the 70s, computer science was, quote, moving too fast. And it's like the journals are slow. And this is like in an era before desktop publishing, right? So you would send something into a journal and it would be published like 9 months later. You know what I mean? I think it's like, I think that there is a legitimate, in that world, which is now so distant, there is a legitimate thing to say, like, no, like we are moving faster than that publishing thing, that publishing wheel can turn. And I think what actually happened is kind of interesting is that I think every other discipline now moves as fast or faster. Right. And so ultimately, clearly the publishing models had to change. But computer science, this became entrenched in computer science. And now, it's one of these things that everyone thinks the system is broken and no one feels empowered to change it. So people are like, no, because now you have to have these gigantic program committees for these conferences in order to have the workload. And it's like now being on the PC is part of the thing you need to do to get tenure. So if we eliminate those PCs and have them be standing journals like other disciplines do, how do these people get tenure? And you're like, what problem are we solving here?
Exactly.
It's like, I feel like it's like, okay, so we're solving like OKRs or conflicting MBOs or whatever. You're kind of, I feel like, so you kind of have like this conference model is just. And I was, very, even for me, I was definitely hot in that ATC keynote. And the reaction actually was interesting. There were some people who were very offended by it. But I remember, and you can hear it on the audio, a guy kind of calling me out afterwards, being like, you should not be saying this about that program committee because people will get the impression that happens on many program committees. And that was just the program committee that you're on. It's like, all right, dude. But I was like, okay. I was on one program committee and this is what happened. So I don't know what do you mean to do? I mean, it's sure they're not all crooked. Congratulations. I mean, the problem the model itself is broken. And one thing I did definitely called out there, because I actually think one of the papers we love started by co-founded by our colleague Zishan, I think is great, where you go back to some older stuff that's really great and bring that to the practitioner. I love that model. Mm-hmm. And so Systems We Love was really me trying to how do we get something that practitioners are going to let's get a conference where we can talk about interesting work in a way that is exciting for practitioners and is not going to look like an academic. And so that's good. And also unspent marketing money. Fine. And also and we need to spend $40,000 in 6 weeks or whatever it is.
And Papers We Love, it was not, I think any of the people presenting, it was not their own work, right? It was systems that they were consumers of and had really demonstrated that it was not like a fluke, but durable.
Yes. And I thought that was great. That was
a great conference.
It was a lot of fun. And the videos for that are still great. And the problem is that we just didn't, we didn't have unspent marketing dollars the next year. So it was kind of a one and done kind of a thing. And then the other thing I think that, as I've kind of reflecting on this more and more, it's like also, in terms of talking about system software, like open source is really important. That's, World War II is stressful. Open source is important.
Seems right.
But this is like where it's like, and obviously we know it's important, but now going back to looking at it from 20 years ago, it's like, man, it is so important because so many of these systems are now effectively published via GitHub.
Yeah.
And we consume Go from raw Pike, but like Rust, Rust is like, it's kind of amazing to me. I don't know. Do you think it's kind of amazing that like a new programming language has been so profoundly important to both of us? I just feel like if you go back to my past self from 20 years ago, I would be surprised to learn that.
Yeah, I will tell you when for sure, when I joined Oxide or shortly after I joined Oxide, I thought, a language is a language. And there were people who loved C and loved Java. And I was like, whatever. I don't think I'm capable of that kind of love. So it was very surprising to me that, in fact, I was not dead inside, and I did learn to love a language.
Yeah. Well, because I think that there was this dichotomy that programming languages, I felt like, there was actually kind of this interesting dichotomy in terms of like maybe almost like that academic practitioner dichotomy played in the small of like, the interesting programming language work is not applicable to the practitioner. And the stuff that is applicable to the practitioner is like pretty like so you've got, this idea that like, well, in order to advance the practitioner, you can't do anything new, or you have to like bring along all these existing semantics. And then we end up with like C++, right? You kind of end up with like the worst of all worlds. And I think like we had a couple different languages that kind of split that false dichotomy. And especially again with Rust, where it's like, no, we actually can bring these very important ideas in a way that's very relevant to the practitioner. It's pretty great.
No, you're right. And I had previously observed or felt like programming language research was not that interesting to me, unfairly, because it lacked the applicability. You know what I mean? Because for example, as an undergraduate, we taught OCaml, a version of OCaml so early that the error messages were in French. I'm not making this up. And I loved OCaml.
Mon Dieu! Was it like I got like
a sort of a sacre bleu.
I'm sacre bleu. I've got like a Tintin kind of like vibe to it,
Yeah. I loved OCaml. And I was like,
yeah.
But it was just like, yeah, that's for classwork. But like, I'm not gonna go build anything real out of it. And of course, people are building real stuff out of it. But it didn't. It felt like there were very few choices when it came to doing stuff that outside of an academic context.
Yeah, and the stuff that you would actually use just grew up gritty as hell, right? You're just like, and okay, we had C, but then it was like Perl, which is just like utility. Only utility, like no sense, and C++, all these things that are just like pretty gritty and gross, and we just kind of had like, well, there's no alternative, and it's pretty great that we.
Well, Java was the alternative, right? Java was the emergent, clean, like the brave new world, such as it was.
But then you sacrifice all these other things with Java. It's like, okay, Java's great, but you can't actually use it on the systems that we care about, right? We actually can't. Right. Like Java's fine and valuable for some stuff, but like
Java's fine and valuable for some stuff. I think it's fair. I think that's a fair.
It has no unsigned type. It has no unsigned type.
I'm not saying it's applicable to all things. I just think it may be underselling some Java slightly.
Look, Java beat us
fine.
out for best paper in ATC 2004, and I'm still better. No, okay, fine. Yeah, okay, Java more broadly relevant. I should, but it's like it was never going to be useful for the software for in kernel for software for operating system software. It's like you just were not going to use it.
100%. I totally agree with that. I think absolutely.
What is your introduction to Haskell? Because I think you and I have the same introduction to Haskell.
I don't think I've actually written any Haskell. I think
it's the first time you learned about Haskell at a debug 2003.
Oh, probably yes.
Do you remember when trying to solve an NP-complete problem to be able to generate an error message that would give you any? Do you remember this?
Oh yeah, I do remember. I was like, well, like the Haskell type system is NP-complete, therefore, and you're like, okay, just stop right there. Like I have lost interest.
I just remember being like, I've just heard about this language for the first time, and I am crossing it off the list. It's like we have that. So I think it's like it's pretty great that we have been able to generate a real innovation for the practitioner that is not quite coming out of the academy, but it's coming out of this kind of netherworld of the open source work that, happening at Mozilla or happening at Google for Go, that is is at once kind of like practical and yet open-ended and not having an immediate deliverable. Like that kind of work actually ended up being extremely important.
And in the case of Rust, and I think to a lesser degree of Go, but maybe that's not fair, really extremely well informed by all of the research that came before it, right? Like just
yes,
not obeisant to it, but certainly deferent of it and respectful of what had happened before, so that like the good parts of OCaml or Haskell, no, not Haskell. The good parts of those languages, or the applicable parts of those language, did make it into Rust in some form.
Totally. Yeah, I would say Go has less of that property. I think Go could maybe, and I think it might have been part of Go's problem.
I think that's fair.
When apparently a bunch of like the inspiration for this is where you got to get like Klabnik going on the operating systems that like, so apparently Simula and Clean, have you heard of Clean?
Maybe from Klabnik, but that's
right, exactly. And this is where PL people are like, are they seriously just learning about Clean for the first time? I mean, are you really? Like, this is, but I don't know. Apparently, I love that about Rust, right? They're like kind of pulling in all of like those great ideas. But I think that like that necessitated the like open source is what allowed all that to happen. I don't see how that happens in a proprietary world. I think that has to be open source.
Yeah, I think you're right.
And so I just think that like that this is part of the reason why that kind of conference model. I mean, and this is before ATC was crashing on Osti's couch. I mean, it was beginning to really erode quickly because like this is only existing as an academic vector. Like there's no reason for the practitioner to go here whatsoever. And I think it's. I feel like I definitely feel ambivalent about them. I think it's probably for the best. I think it would maybe allow them to do something different. You know what I mean? Like I would like Usenix to experiment with different kinds of ideas, and like how do we get to some of the things that conferences get to? And we talked about this, and we had a great episode with Theo and Stephen Brady, and Kellyanne on conferences, right? And like, what are some of the challenges of conference? But like, how do we kind of get to some of that stuff where we get the practitioner to the kind of that advanced practitioner, the practitioner, the academic, to really intermingle their ideas? Because I do think that like that's the bit that we do. I think it's valuable, right? I think it's given us some great stuff, and I think it's important that we kind of continue to do that.
Yeah, for sure. I mean, I think I'm not sure how that cross-pollination really happens effectively right now. Like, I think there's kind of sponsored research across these different organizations, especially when you get to really big companies that are investing in the universities. But it seems narrow, and it'd be great to see more inspiration from in both directions.
Yeah, I think so. And I think it's like, how can we? I would like to. And I know this is tough because I know that this is all like wrapped up in the tenure model. But man, it would be nice to incentivize academics to produce quality work, which I know sounds pejorative the way I'm saying it, but you know what I mean? It's like, it would be great if
indexing it on the quality. Yeah.
Indexing it on the quality and using the quality to get, and I know it feels like very difficult to kind of change the domain in that way, but man, you could do like, it would be great if you could incentivize that and incentivize people to kind of like to find the quality would be really and like, how do you kind of allow that to, you know, how what systems do you have to kind of encourage that quality? And I don't know the answer to that. Hey, how do we get Tom up on stage? I need to. Tom's here.
Let me grab him. Yeah.
Tom I know has definitely had some ATC back in the day. Tom, how are you?
I am good. I wanted to steer you back towards Usenix history.
Absolutely. Yeah, do it.
Mostly so I can brag about things. But, Usenix ATC was just a rename of the main Usenix conference when they started having more conferences. And the Usenix itself was an outgrowth of the Unix users group, which started in 1975. And I missed the first meeting, but I went to the second meeting of the Unix users group.
Oh, wow. And so the Unix users group, and so that is that's what kind of begat Usenix, right, Tom? That's when Usenix grew up. And I mean, am I wrong to lionize some of those? I mean, I just look at those Usenix proceedings from the 80s and 90s, and you're just like, it's like Renaissance era Florence. It just feels. A couple of things. The sense of urgency was there for the practitioners to connect with other practitioners. Interesting.
Because the Unix community, we were like the Rebel Alliance, right? It was not how things were done, and it was a fantastic community. And so a couple of hundred people, changing the world. It was great stuff.
Well, and you also, it's kind of hard to convey how distant that world is, where it's like, they don't really have, they can't hop on a Zoom call together, right? I mean, this is the way, they don't have other ways of actually connecting.
Right. Yeah, and so it was, if you were lucky, you were on Usenet and you could send email, but it's hard to talk to lots of people at once that way. And just the social aspect of things and keeping track of people moving around between companies and yada, yada, yada.
And so Tom, did you having been to those, just kind of been through that extraordinary time? I mean, did you feel kind of bittersweet about this announcement, or are you kind of like, hey, I think it's like time to wrap this up?
Yeah, I had kind of given up on the conference aspects of Usenix because, again, like you said, it's all gone academic, and that was happening starting in the early 90s, I think. And actually, somewhere I saw a rant by Clem Cole talking about his experiences on the Usenix board and how it was being dragged towards that academia, and he really wanted to keep it in practitioner land.
Where would I find that rant? That rant I would like to inject in my veins, I think.
It might be on the Unix Heritage mailing list.
Oh, there we go. Truly down at the home, Adam. Have you been on the Unix Heritage mailing list? This is where it's good stuff.
Nice.
If you really want people to get off your lawn, that's the place to go. At some point, Adam and I are going to come to the episode from your house where we're going to go through the recall from Books on the Box episode. But we'd love to see some of those old artifacts. And so Tom, when was the last kind of did you stop going then in the kind of the 90s? Is that when you?
Yeah, it was pretty spotty. Even kind of late 80s, I got kind of too busy to keep going all the time. The last one I went to, though, was 2019, where they were having an associated 50th anniversary of Unix meeting. And that was in Seattle, and they had the meeting at the Living Computer Museum with the recreation of the PDP-7 Unix version 0. So that was all very cool.
And the Living Computer Museum is struggling the living part of the Computer Museum in the Living Computer Museum is a bit of a struggle at the moment, isn't it? I think
it's gone. They closed it down. They auctioned off the machines. The remaining outposts are these SDF guys who took a handful of the machines and have them running. Anyway, I did have a couple of papers at Usenix back in the day. And 1985, I think, was all the chips that fit, which is a good rant about how screwed up hardware was.
So all the chips that fit. Okay. We'll have to go find that one.
Yeah, it was kind of a long, steady slide to pure academia, and boy, it really pissed me off that the academics pursue these completely meaningless goals. And sometimes they're funded by the industry to pursue those meaningless goals. And I'm pointing my finger at Intel and persistent memory.
Oh,
I got so sick of saying persistent memory papers.
Adam, we need to have a chime when we reference previous episodes. I really love that. This is what Adam does in the changelog, where they have a chime whenever they make a Silicon Valley reference. We need a chime that we can ring with now Tom referencing our Optide episode where Tom said that it was a funeral for a goldfish, which I still chuckle at. I feel that Optide, there was that era when it was definitely overpublished, as one might say.
It's still going. People are still publishing stuff about persistent memory. It's like, why? The academics just get totally disconnected from the state of the world.
Yeah, it'd be nice to get them kind of reconnected. Adam, you got the excellent. Look at that. Tom, there's a section called Unholy Wars in here. That's pretty great. All right, I'm going to have to go read this. This looks great. Usenix back in the day. So Tom, go ahead.
I forget what else I was going to rant about, but it was a fantastic community back in the 80s.
Yeah, and I did feel like there was Adam, when this was being discussed on Hacker News, someone was like, ATC was not even a prestigious conference like OSBI or SOSP, and I'm like, you academics killed it for nothing. Then I mean, like there's always that. So that was a little. I think it's unfortunate that we ended up in this phenomenon where this conference became popular with practitioners, attracted a lot of people attracted the academics, and the academics then drove away the people that were going there. That's bluntly kind of what happened. And then it was crashing on Aussie's couch for a while, and then Aussie told it, you can't stay here. RIP ATC. Well, yep. Adam, we're always going to have 2004.
That's right.
And whatever beat us out for best paper, which I've obviously blotted from my memory.
Yeah.
I need to go remind myself of that so I can harbor that resentment. Unfortunately, really lost track of that. We're gonna need to do like a "Where Are They Now" episode with whatever beat us out for best paper.
That would be a great retrospective conference. That might look really silly.
That would be interesting. And I do think that more. My favorite conference, I think we talked about it here before, but like history of programming languages is a great conference because people have to talk about systems that have been deployed for over a decade, and I think that's like more of that stuff. I think is really great.
Yeah.
So, RIP Usenix ATC. We got the opportunity to chase Dennis Ritchie into a bathroom, and
we'll always have that.
We'll always have that, and we didn't actually stake you out. We let you leave. All right. Well, again, apologies for all my reverb, Adam, but thanks for Tom. Thank you so much for joining us. As we reminisce about ATC, and Yeah, we'll see folks next time.